Hello students. Today we'll be continuing the another session. Okay. Last class we have done the motion on the or we can say it as a vertical motion, right? Where you replace acceleration in terms of acceleration due to gravity, and we will replace in terms of h. So today we'll be discussing on relative motion. Okay, so relative motion will be coming forward in 2D motion also, but here we will be discussing relative motion of 1D car. Okay, there are 2D motion also, but after doing that motion in 2D we'll be going again with relative motion in 2D. So today we will discuss on relative motion in 1D. Okay, so before going forward on relative motion, we should know a few terms. Okay, like for example, particle. Oh, particle. Can we think about a particle? Like, how do we imagine a particle to be in physics? So we feel like a particle is a small object, a small atom, a small element, okay, etc. So this is the one of the definition too. But in physics, we usually take particle as a object which is having a definite size and a shape. Okay. First thing, it has a definite shape and size. Okay. Another thing is a particle is a point mass. It has a definite shape and a point mass. Okay. Now, and even if I want to take a good example, I'll take an example of a car. Okay. Think that we are traveling in a car from one place to other place, which is around 256 kilometers far away. So in that 1D motion or in the straight line motion, the car is moving along 256 kilometer, right? So that 256 kilometer which a car is traveling, I can take it as particle for a car when compared to the distance it traveled. So dimensionally, if you want to take, if you want to speak, I'll take car as a particle in terms of the distance which it has covered, or which it is going to be covered, or it has covered. Okay, now we can say dimensions. Dimensions are very small when compared to the distance. When compared to the distance traveled by it. Okay. So this is how we define a particle. Now moving forward, we should know what is the difference between rest and motion. Okay, another term, rest and motion. Okay, now when we talk about rest and motion, we say that if a particle or a body does not change its position in the with its surroundings in the given intervals of time, so then we say that the particle is at rest. And a particle will be in the motion if the body changes its position in the given interval of time or in the equal intervals of time. So that thing is, we call it as motion. This is absolutely correct answer. Okay. So apart from rest and motion, okay, apart from all these different definitions, we have to know that the rest and motion depends on the frame of reference. Okay, what is this frame of reference, or we can call it as an observer. Okay, and we say that, for example, a book is placed on the table, okay, with our respective or the person next to that book, or a person who is looking to the book, you feel that the book is at rest, right? But actually the book is in motion for the person who is looking outside the earth. If we say standing outside the earth, if you look towards the book, feel that the book is motion because earth is rotating, right? So in that sense, or in that frame of reference, that book will be in the motion. So to define rest and motion, we should know the term called frame of reference, and also with respect to what, with respect to which observer you are telling the object is at rest or the object will be in motion. Okay, so this definition you have to remember. So if a particle occupies the same position, we can say a particle occupies the same position in all times with respect to surroundings. So this is the definition of rest. Motion, you say, different positions. Okay, now we'll be talking on frame of reference. Okay, another important topic, that is frame of, or we can say reference frame. So as I said before, a reference frame is the frame where an observer is taking the complete observations of that body or the particle. So how we observed, how he is observing with the help of the clock, right? He takes the clock and then he observes the observations. So we can define frame of reference as, it is a region where observations are taken, you can say region where observations are taken. Can you tell me what kind of observation that observer is taking? He is taking the observations of motional parameters. Motional parameters. Okay. So he is taking the observations of the motional parameters. So such thing is called as frame of reference. So after knowing the difference between rest and motion and frame of reference, I want to give some example where you have a clear picture how the observations are and how the motional parameters varies, okay, according to the frame of reference. The other point I want to add in reference frame is, you can say reference frame can be at rest or motion. So even though the reference frame, if the frame is at rest, we can consider it as a reference frame. Or if the frame of reference which we are considering, if it is motion, you can take it as the same as it is. Okay, so this is the frame of reference. Now we'll move on. I'll give some example. So there is a person standing on the ground. Okay, this is a ground. Now there is other object x which is moving at 10 meter per second. Now here, with respect to this man, the body x which is moving at 10 meter per second also feels that when you measure the velocity, which is the motional parameter, okay, when you measure velocity with respect to this frame, this ground person feels what? The x body is moving with velocity of 10 meter per second. Correct. So with respect to this person, the body is moving at 10 meter per second. Now what if, other example, this is a trolley. Okay. Here a person is on the trolley and the trolley is moving at 10 meter per second. Now, if you want to measure the velocity with respect to this person who is standing on the trolley, okay, when you measure the velocity, that person feels that body is at, he feels that body is at rest. But if you measure the same body ka velocity with respect to the person who is standing on the ground, he feels that the x is moving in 10 meter per second. If the same person stand on the same object, or you can say a trolley which is moving at 10 meter per second, he feels it, the body is at rest. Correct. So this is another example. So if you want some more example on this, okay, now we'll consider there is a ground, okay, a person is standing on the ground and there is a car which is moving at 3 meter per second. A person A is standing and there is a car which is moving at 3 meter per second. Then if I want to measure the velocity of this car with respect to this person, I will write in this form: velocity V, velocity of C. We are finding the velocity of C with respect to what? A. Right. So here velocity of C with respect to A is nothing but VC minus VA. Correct. So here we will write the velocity of the car C with respect to A, the observer who is standing on the ground. Okay. So I will write VC minus VA, and this velocity of the car is 3 meter per second minus velocity of the person who is standing on the ground is what? 0, because he is at rest, right? He doesn't have any velocity. So we can find velocity of the car with respect to A is nothing but 3 meter per second. 3 meter per second. This is how you write. So similarly, Now, if I take another observer, okay, another observer on the a trolley, okay, there is a trolley and a person is standing. This trolley is moving at 1 meter per second. So this is an observer B. Okay. If I want to know the velocity of the car with respect to this observer B, how will you write? You will write VCB is equal to VC minus VB. So here, this is velocity of the car is 3. Now, if I want to know the velocity of the car with respect to this trolley is moving at 1 meter per second. That is B. VCB is nothing but 2 meter per second. So, this is how we will write. Okay. So, when we take different example, we came to know that how the frame of reference is very important, right? So when the body is of rest, the velocity, that is the motional parameter, how it is varying. The body, when it is attached to the moving trolley, how the motional parameter is varying. So finally, I'll make a statement saying that a frame of reference is a coordinate system with a clock for measurement. I'll say that a reference frame is a reference frame is a coordinate system with the clock for measurement. Clock for measurement of time. It can be at rest, that is on the ground, or it can be attached to a moving body. So this is a very important definition of frame of reference. moving further, we'll do some problems on relative motion. Okay. Now, in the coordinate system, we know from the origin, this direction we call it as, we will take it as positive. This will take it as negative. Okay. I'll give you case 1. Okay. Consider there are two bodies, A and B, having a velocity VA and VB. Now, if you want to find the relative velocity of B with respect to A, this is nothing but relative velocity of B with respect to A. Now, this VBA can we write it as VB minus VA. That is when bodies move along same direction. Similarly, in case 2, if the bodies move in different direction, the bodies move in different direction, you will write it as velocity of B with respect to A is nothing but VB plus VA. So these are the two cases you have to consider. Now we'll do one problem based on relative motion. Problem 1. An object A is moving with 5 meters per second. So A, or you can say an object A is moving with 5 meter per second and B is moving with 20 meter per second. B is moving with 20 meter per second in the same direction. In the same direction. Now we find velocity of B with respect to A and velocity of A with respect to B. These two things you have to find. So here so they have said they are moving in the same direction, right? So they have said velocity first of B with respect to A, which is equal to VB minus VA, correct? So here VB will be 20 meter per second minus VA is 5 meter. So here 20 minus 5 is 15 meter per second. So this is the velocity of B with respect to A. Now similarly, other part of the question they have asked velocity of A with respect to B. This is VA minus VB. Correct. VA is nothing but 5 minus VB is 20. So this is minus 15 meter per second. So here the magnitude is same 15 and 15, but with respect to A or with the velocity of A with respect to B, it is negative. So here for the velocity of B, when he is looking that from a frame of reference, feel that it is 15 meter per second. That means it is increasing, right? Velocity is increased. But here with respect to B, with respect to B, if you measure the velocity of A, he feels that the B observer feels that it is decreasing, minus sign. So this is the two velocities with in different frame of reference. So another example. Okay. There is a two object which is moving at 10 meter per second and 12 meter per second. Okay, there is an object which is moving at 10 meter per second. This is moving at 12 meter per second. So this is A and this is B. So here first part of the question is you have to find the velocity of A with respect to B And second, find the velocity of B with respect to A. So here you have to see that since they are going in the different directions, right? I said to add it here, but B ka velocity is greater and A ka velocity smaller, right? So here, if you want to know the relative velocity of A with respect to B, generally we write VA minus VB, right? This is the usual formula. So now, but VA velocity is moving the positive x direction. So it is plus 10 meter per second. Okay. Similarly, for the velocity B, it is moving in the negative x direction. So I'll write it as minus 12 meter per second. Now what I do, I'll substitute here velocity of A with respect to B. That is VA minus VB. VA is 10 minus of minus 12, that is 22 meter per second. So this is why I said when the particles or the two bodies moving in the opposite direction, you add it. So but here the second body is having the greater velocity, then it comes positive. Okay, we'll do the second part. Second part is velocity of B with respect to A, right? That is VB minus VA. And VB is 12. VA is, so VB is minus 12, VA is minus 10. So this will be 22 meter per second. So here with respect to B, it is velocity of A is 22 meter per second. But same thing, if you observe the velocity of B with respect to A, it is negative of 22 meter per second. So this is the relative motion. But with this as a greater and this is a minus sign. So here we should know which body is having the greater velocity and which body is having the least velocity. Okay. So in the second part, when I said to add those relative velocity, right? So this concept you have to remember why we are adding. Whether the first or the second body having a greater velocity or lesser velocities. If it is having the greater velocity of the body which we are measuring from the frame of reference A, the negative side comes in the picture. Now we'll do some more examples on it, okay? Further, further, relative acceleration. Okay. This relative acceleration is will find it is the similar way how we find the relative velocity. Okay. Now here, if you want to find the acceleration of A with respective to B, we will write it as acceleration of A minus acceleration of B. Similarly, if you want to find the acceleration of B with respective to A, we will write it as AB minus AA. So same thing we are applying for acceleration, that is relative acceleration. How did we apply for the relative velocity, right? Same theory will be applied for the relative acceleration part. Now we know the equations of motion, right? Which we have done. So here equations of motion. So we know V is equal to U plus AT, S is equal to UT plus half AT square, and V square equal to U square minus 2AS. Correct. So all these equations were valid when the acceleration was constant. So here same relativity concept we can apply to the equations of motions also, but the condition is acceleration or relative acceleration must be constant. When this is valid, you can apply the relative concept to the equations of motion. Just we have to replace velocity by relative velocity, acceleration by relative acceleration, correct? Distance by relative distance, or you can say, I'll write it as REL. This is also relative acceleration, relative velocity. So all these equations I'll replace in terms of relative velocity, relative acceleration. Okay. So these three things you have to note down. So another thing I have to introduce about velocity of approach or velocity of separation. Okay. Here velocity of approach and velocity of separation is the same thing which we have done in the previous problem. So if the two bodies are moving here the in opposite directions, distance decreases, right? Distance decreases between the two. So this we call it as velocity of approach. Okay. Similarly, if these two bodies are moving away, your distance decreases. So this we call it as velocity of separation. So these two things you have to remember. For this we are naming it. One is velocity of approach and velocity of separation. See, another thing is here the relative velocity is along the line joining the two bodies, right? So in such cases, we just simply we say that it is equal to the magnitude of relative velocity of A with respect to B. So here we will take only the magnitude part in both the cases, because both the things are we measure along the line joining the two objects, right? So in this case, we'll take it as only the magnitude part. I have given one example, right? We have taken a body which is moving at 10 meter per second and another body which is moving at 12 meter per second, right? So here this is A and this is B. So velocity of A with respect to B. Here you can see the distance decreasing. When the distance decreasing, we call it as velocity of approach. So this is nothing but VA minus VB. So VA is 10 minus 12, it is 22 meters per second. Similarly, if you want to find B with respect to A, that is VB minus VA. This is minus 12 minus 10. That is minus 22 meters per second. So here, if you in a relative that means velocity of approach is velocity of separation, we will take only the magnitude part. Okay, so the magnitude will remain same, right? Because both the bodies are along the line joining. Okay, now another example. A particle A is moving with a speed of 20 meter per second. Oh, there is a particle E which is moving at a speed of 20 meter per second, which is towards right, and another particle B which is moving 5 meter per second. This is also is moving towards right. They have said find the velocity of approach. So here velocity of A is 20 meter per second and velocity of B is 5 meter per second. Since they have asked velocity of approach, we have to find velocity of A with respect to B. That is VA minus VB. So VA is 20, VB is 5. So this is 15 meter per second. So velocity of approach, if you take the magnitude, still you'll be getting 15 meter per second. Okay. So these were the simple examples on relative velocities. Okay. Now we'll do another problem based on relative motion. Okay, they have shown in the another example. Okay, they are shown in the diagram. So there is a tower of 100-meter height. There is a person here. Okay, now the below person is throwing a ball. Below person is throwing a ball of 5 meter per second velocity, and above person is throwing a ball with 10 meter per second velocity. Here we have to find the time. We have to find the time when both balls will collide. So here in this such problems we can apply relative velocity ka concept, or we can say relative motion ka concept. Here in both the cases, if you take this as A and B, okay, here the acceleration is due to gravity is downward for this ball. G is downward, right? So here, since both the acceleration due to gravity is downward, so here we can say relative velocity of B with respect to A, relative acceleration of B with respect to A is 0, right? Acceleration term is will be 0. Now about velocities. Velocity of B with respect to A will be VB minus VA, right? Opposite direction, so VA will be negative. So this is then if you take this is observer B and this is A. Okay, so VB minus VA 10 minus VB is 5. If I take upward direction as positive and downward as negative, minus 10, this is 15 meter per second. So here they have asked you to find time, right? So time is equal to distance by velocity. Here velocity is replaced by relative velocity. So time equal to distance is, or the height is 100 divided by relative velocity, that is 15. So this will be 0.15 second. So this is the time required for the two balls to get collide with each other. Okay. Now we'll move on to the another question. Question number 3. In question 3 says that two cars moving towards each other at velocities VA and VB. There are two cars which is moving at velocities VA and VB. Okay. At a separation D. So there is a separation of D distance for A and B. And now at this instance, both are retarded with acceleration AA and AB. So at this instant, the acceleration for both is retarded by AA and AB. So your retardation is what? Retardation is a decrease in the acceleration. So your acceleration will be in the opposite direction to the velocity since it is retarded. Correct? For both the cars. They have said find minimum value of D such that no collision occurs. find minimum value of D such that no collision occurs. So here for the, I can use one of the kinematic equation, that is V square equal to U square plus 2AS. Since they have said no collision occurs, the final velocity should be 0. That means the body or the car should be stopped, right? So when this is 0, I will write it as U square plus 2AS. So here I can apply the relative motion ka concept. So here velocity u, I will replace it is by relative velocity. For acceleration, relative acceleration. So here velocity of A with respect to B, this will be VA, minus of minus will be plus VB. Okay. Similarly, if you want to know the acceleration with respect to acceleration of A with respect to B will be, the both acceleration are retarded in the opposite direction, right? So here also I will writing it as A plus AB. But since they have said it is retarded, I'll put a minus sign to say that they both the acceleration are retarded. So simply I'll put these two in the equation, that is VA, or simply I write it as UA plus UB whole square, or I'll take it as VA plus VB whole square plus 2 into relative acceleration minus of, or I can say 2 into minus of AA plus AB. S is D. So your D value is equal to VA plus VB whole square divided by 2 AA plus AB whole square. So this is the minimum value required so that no collision occur. So this is the minimum value of distance so that no collision occurs. Now, one more example. Here, a balloon is rising at a 20 meter per second. This is a balloon which is rising at 20 meter per second, which is placed at a height of 100 meter above the ground. Okay, this is 100 meter above the ground. So find the time after which the stone will hit the ground. So a person from here is throwing the stone. So we have to find the time. Find the time. Find the time after which the stone will hit the ground. So here U is 20 meter per second. G always acts downward. So H is minus 100 meter. G is minus 10 meter per second square. So here H is equal to UT plus half GT square. Correct. They have asked to find the time. So this is minus 100 20t minus half g t square. Or you can say it as 5t square. Because g is 10, 10 divided by 2 is 5. So this is so here this, if I take 5 common, this will be 2 square, sorry, t square minus 4t. If I divide it by 5, minus 20 equal to 0. So this is a quadratic equation, right? So here, if you solve for time t, this is x is equal to minus b plus or minus b square minus 4ac divided by 2a. So here a is equal to 1, b is equal to minus 4 and c equal to minus 20. So this will be 4 plus or minus 16 minus 4 into 1 into 20. So this is divided by 2 into 1. So this is t is equal to 4 plus or minus under root 16 plus 80 divided by 2. So this is 4 pi 2 plus or minus 96 divided by 2. Correct? So here t is equal to 2 plus or minus will be under root 24. Since time cannot be negative, I will take only the positive values. That is t equal to 2 plus under root 24 second. So this is the time required for the ball to hit the ground. Now we have done few problems on relative velocities, right? So we will doing 2 more problems to see how the it is applied in the different concept. Okay. So another problem. There is a person who is standing on the ground and there is a trolley. There is a trolley. On that there is a person. Okay, and the trolley is moving at 10 meter per second and the person is moving at 2 meter per second. So this is M. This person is A. So if they tell you to find the velocity of A with respect to M, how will you find it out? We know it is VA minus VM. Clear? So now VA velocity is 2 meter per second, right? With respect to what? With respect to the trolley. So this VA is nothing but the relative what we are finding is nothing but with respect to ground. M with respect to ground. So here VA with respect to ground we don't know. We know VA with respect to the trolley. So what we do is we write what we know velocity of A with respect to trolley. We know. So from this we know it is VA minus VT. I have already said this V and VT is nothing but these are the velocities with respect to ground. So this is G. So VA with respect to T is what? 2. VA with respect to ground we don't know. But velocity of velocity of trolley with respect to ground is 10 meter per second. From this you can find VA with respect to ground, that is 12 meter per second. Correct. So I can take this 12 meter per second and substitute in this equation. That is 12. But Vm with respect to ground is 0. So this is 12 meter per second is the answer. I will take another example. So here, when we are finding the velocity of A with respect to M, the M was at ground. That means the M was on ground. So what if that M is moving now? Okay, this is a car on which the person M is moving with 30 meters per second and there is a trolley which is moving at 10 meters per second. and there is a person on the trolley which is moving it 3 meter per second. So if you want to find the velocity of p with respect to m, that is vp minus vm. This vp and vm are with respect to ground. Vm with respect to ground we know that is 30 meter per second. But Vp with respect to ground we don't know. So but we know Vp with respect to trolley, that is Vp minus Vt. So Vp we need to find out. Vp with respect to trolley is 3. 3, that means it is going in the other direction. Correct. So I'll let it as minus 3. And velocity with respect to trolley is 10. So minus 3 plus 10 is Vp. So Vp is nothing but 7 meter per second. So I'll substitute here. Vpm 7 minus 30. 7 minus 30. So this is minus 23 meter per second. Okay. So this is in different cases we apply relative motion with the different motional parameters, maybe relative velocity, relative acceleration, and apply in the problems to solve the questions. Okay. So today's session we will end. Next session we'll be doing different problems and we'll go to the projectile motion and be doing some different problems on it. Okay. And one thing you have to remember that the relative motion, this is today we are studying was only of 1D. So again, we'll be studying relative motion for 2D also. Okay. So to start with the 2D, we have to know what is 2D motion. We will take an example of projectile and we'll continue. Okay. Thank you, students. Hope you understood.